Okay, so today we're going to be looking at 4.7, which is patterns on the multiplication table. We have one of these on your desk, but I know you're not at your desk right now, but we have something similar right here. So we have a 0 section in it. What we're going to get good at is filling this in. So look at number 1. Now we're supposed to be using a math board for this, but we're going to do it on here as much as we can. It says write the products for the green squares. Well, here are our green squares. So we have 0 times 8, which is 0, 7 times 1, which is 7, 2 times 6, which is 12, 3 times 5, which is 15, 4 times 4, which is 16, and then we go back down. 3 times 5 is 15, 2 times 6 is 12, 1 times 7 is 7, 0 times 8 is 0. So what do we know about these products? They start at 0 and go to 16, and they go from 16 down to 0. So they go up, they start at 0 and go to 16, then back down. And I apologize if I sound a little funny. I got my wisdom teeth cut out. So they start at 0, 7, 12, 15, 16, 15, 12, 7, 0. They go up and they go back down. Let me erase this because it's not. What do we notice about the products? Well, we notice our products is we're using commutative property. For example, our first problem is 8 times 0 which equals 0. And our last one is 0 times 8, which equals 0. So they use commutative property. We're using commutative property. We have 8 times 0, which is 0, 7 times 1, which is 7. Over here, we have 1 times 7, which is 7. So 7 times 1 and 1 times 7 is the same thing. For example, 6 times 2 and 2 times 6 is the same thing. Will this be true in the yellow squares? Well, let's try the yellow squares. 6 times 0 is 0. 5 times 1 is 5. 4 times 2 is 8. 3 times 3 is 9. 2 times 4 is 8. 1 times 5 is 5. 0 times 6 is 0. 0, 5, 8, 9, 8, 5, 0. Yes. Yes, this will be true because we're just swapping numbers. Yes. It uses commutative property. Because look, 5 times 1 is the same as 1 times 5 right here. If we're using this line, let's go 5 times 1, which is 5, or 1 times 5, which is 5. For example, 4 times 3 or 4 times 2 is the same as 2 times 4. So these right here, guys, they're the same value. They're just switching places, 4 and 2 and 2 and 4. These two are the same. They're patterns you got to look for. It says write the products for the yellow squares. We've done it already. And then complete the columns for 1s, 5s, and 6. So they want us to complete the columns for 1, 5, and 6. So let's do 1s. 1 times 0 is 0. 1 times 1 is 1. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we're going to do 5s. 5 times 0 is 0. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? And then 6 is 0, 6, 12, 18, 4, 30, 36, 42, 48, 54, 4, and 60. And if we would do, 10 across, we would still get 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's 6 is going to be a little bit tough, and hopefully some of you guys might have a multiplication chart with you, but it kind of helps you see. We're just skip counting by 6. For example, 10, 12. These should be 3 apart. These should be 4 apart. These should be 5 apart because we're 5. These should be 6 apart because we're 6. These should be 7 apart, 8 apart, 9 apart, 10 apart. What do you notice? They skip count. And are separated. They skip count and are separated by the row number. For example, like I said, these two numbers should be 2 apart. These should be 2 apart. 2 apart, 2 apart, 2 apart. These are 4 apart. These are 5 apart because we're in a 5s column. These are 6 apart because we're in a 6 column row. These are 7 apart because we're in a 7 row. 8, 8, 9, 9, 10, 10. Okay? These are 1 apart. These are 2 apart. What does this property show? Oh, this shows commutative property and identity property. Commutative and identity property, because the 1 showed the identity. Commutative property and commutative and identity property. This one, it says we're going to use crayons. Well, we don't have crayons, so I'm going to circle. I might see if I can highlight. I changed my color. Yes. So I'm going to highlight. It says shade the rows 0, 2, 4, 6, 8, and 10. So started to work. Oh, there it is. So we're shading our rows. 2, 'Oh, it's not going to work. All right, I'm just going to circle. Let me erase this. So I'm going to circle my 2s, my 4s, my 6, my 8, and my 10. So what do you notice about each row? All these numbers are even. They are all even numbers. Let's just compare 2 and 4. What do we notice about the products? Some of the products are the same, like 4 and 4, 8 and 8, 12 and 12, 16 and 16, 20 and 20. Some are the same. Some of the products are the same because some factors of 2, some factors or products of 2 and 4 are the same. Now it says shade the columns for 1, 3, 5, 7, and 9 blue. Well, I should have done it blue. Let me do it purple. I should have done the other one yellow. So 1, 3, 5, 7, and 9. What do we notice about the products for this shaded item? So like we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 6, 9, 12, 15, 18, 21, 24, 27. We have odd numbers, we have even numbers. we have odd and even numbers. We have odd and even numbers. It says compare the products for the green squares. What do you notice about the green squares? Oh, up here. What do you notice about the green squares down here? I don't see green squares. All right, so it says compare the products for the green squares. Well, these are our green squares up here. Let's go with these. 0, 7, 12, 15, 18, 15, 12, 7, 0. So what do these products look like? Well, they are still in here, okay? The factors, some of the factors are the same. Which, you know, some of these factors are going to be the same as the ones in the green squares. So the products will be the same. What other patterns do you see? And this is just up to you. You know, we know the zeros all have zeros because anything times 0 is 0. We know the ones all show the true identity. The 2s skip count by 2s. They're separated by 3. So the pattern that really sticks out to me, and this is different between everybody, is really patterns by rows. So like 10, 20, 30, 40, 50, 60, it's the same as 10, 20, 30, 40. I can take this 0 and bring it down here, and it would match up. Like you could take this 9 and bring it down to this 9, and it would match up. This is the same down as this is across. 8 down is the same as 8 across. So I would say the numbers down, the number going down matches the going across. That's the biggest thing I want you to see is if you look at 7 going from 0, this 7 going down, it's going to be the same exact numbers on this row going down as this column going across. Okay, we're going to use 0, 7, 14, 21, 0, 7, 14, 21. Same numbers going down are the same across. So if you learn how to do a row down, you automatically know how to do that row across. Write the product 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. What describe the pattern you see? We skip count. By 2. Is the product odd or even? Let's see. 5 times 8, if we go up here, 5 times 8 is 40. 6 times 3 is 18. 3 times 5 is 15. And 4 times 4 is 16. So is 40 odd or even? That's even. 18 is even. 15 is odd. And 16 is even. If you have to pause, do it. Use the multiplication table to grab the pattern you see. So in the column for 10, so we go up here. Let's just use this multiplication table. In the column of 10, what do we see? They are all 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. They are all separated by 10. They are all separated by 10. And are even. Because all these numbers are even. Besides, I mean, 0. But 10, 20, 30, 40, they're all even. Now look at the column for 8. What do you notice about this? They're also separated by 8, and guess what they are? Even. No matter what way you look at it. So they are separated by 8. And are even. They are separated by 8 and are even. Now, same thing, odd or even. 4 times 8 is 32. 5 times 5 is 25. 7 times 4 is 28. And 2 times 9 is 18. Is even, odd, even, even. So what they're trying to get you to see here is, and this is something you'll learn, is an odd times an odd equals odd. Okay. And even times an odd is even. And even times even equals even. So the only time we're ever going to get an odd number is if we multiply two odds together. For example, 5 is odd, 5 is odd. So odd times odd is odd. But 7 is odd and 4 is even. But odd times even makes even. Even times even makes even. The only time we ever get odd is two odd numbers. Correct the pattern. 6, 12, 18, 22. That's not right because there's 6 between here, there's 6 between here, and there's 4 between here. So it should be 6, 12, 18. Instead of 22, we should have 6, 12, 18. We should have 24. 24, 30. Separation between 6 between 24 and 30 and 36. So this was the one we was missing. Complete the table. Awesome. So 5 times 2 is 10. 5 times 4 is 20. 5 times 6 is 30. 5 times 8 is 40. 5 times 10 is 50. What pattern do you see? We're skip counting by tens. So we start at 5 and go 10, 20, 30, 40, 50. Because we're multiplying by double each time. 5 doubled. Because doubling 5 makes 10. That's why we're skip counting by 10. 5 times 1 is 5. 15, 25, 35, 45. Keep counting by tens, all even. Now we're skip counting by 10 still. But they all are odd. And why are they all odd? Because 5 is odd, 1 is odd. Odd and odd make odd. 5 is odd, 3 is odd. 5 and 7, 5 and 9. Multiply two odd numbers together, you will get an odd number. But over here, we did odd and even. Odd and even make even. So that explains how the one digit and the products relate to the factors in 13 and 14. The ones digits, for example, we have 1, or explain how we have zeros here and 5s here. We have 0 and 5 in the ones digits, in the ones place. Okay. So we have zeros and 5s. We have zeros over here in the ones place for the products and 5s over here. Okay. How do they relate to the factors? Okay. And we talked about it. Exercise 13 is multiplying by even numbers. And 14 is by odd. That's how we get our 0, because a 5 multiplied, if you multiply 5 by any even number ever, you're going to have a 0 in the ones place. If you multiply 5 by any odd number, you're going to have a 5 in the ones place. Okay? So Helene selected an odd number to multiply. Selected an odd number to multiply by the factors in the table. Right? Even or odd. So an odd number times an odd number makes odd. Odd times even makes even. Odd times odd makes odd. Odd times even makes even. Odd times odd makes odd. Whose statement makes sense? So the product, which is the answer of an odd number and an even number, is even. So these are our rules. Let me write our rules right here. Odd times odd equals odd. Odd times even equals even. Even times even equals even. You need my help? Kate. Caitlin. You need my help? Right here. So the only time we ever get an odd number is when it's odd times odd. So Gunter's saying odd times even makes even. 3 times 4. Does that make 12? Yes. And Giselle says the product of two even numbers. Even times even is even. So really, whose statement is nonsense? Explain whose makes sense and whose doesn't make sense. Well, I'm gonna be honest with you. They both make sense. They both make sense. Odd times odd equals odd. I know that's not 0. And then even times odd equals, wait, I'm sorry, even times even equals even. Even times odd equals odd. So they both actually make sense. The only one that wouldn't make sense is if Gunter would said odd times odd makes even. Because odd times odd always makes odd. It says write a statement about the products of two odd numbers. Let's make two odd numbers. Two odd numbers multiplied together make another odd. Two odd numbers multiplied together make another odd. And let's give an example. Well, let's just do 3 times 3. So if I have 3 groups with 3 in each, I'm going to have a total of 9. My total is going to be 9 dots. Let's say there's a cookies, that's 9 chocolate chips. Okay. So that gives us our example. I know this lesson's pretty wordy. I'm not going to do 1 through 3 with you. I'm going to do 4, 5, and 6 with you because this is a pretty rough lesson. I wouldn't say rough. It's just really, it's hard not to do it in person. So let's look at column 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Let's say we know we skip count 5. The ones place is 5 or 0. You have 5, you have 0, 5, 0, 5, 0, 5, 0, 5, 0, 5, 0. Okay. Now let's look at the tens place. We skip count 10. The ones is all 0. The ones place is all 0. 0, 0, 0, 0, and even. They're all even. Now look at the rows 3 and 6. We know we skip count by 3 and 6. And then we notice that some of these products like 6, 12, 18, 24, some products, so the answers, guys, are the same. You have to pause. Please pause. I know this is a pretty wordy lesson. You guys can definitely do this. I will put this on Schoology for you. You can do it on here or you can do it on Schoology, okay? Yeah, so I will put this on. You guys can fill this out on Schoology or you guys can do it on here, either one. But other than that, you guys should be good to go, okay? Have a good one.